This is R.D. Sharma solution, class 12, chapter 15, mean value theorems. Exercise is 15.1. At what point on the following curve is the tangent parallel to x-axis y is equal to x square on negative 2 and 2? So if I make a Cartesian coordinate system, a line which is parallel to x-axis, that is m tan theta slope or dy by dx. So all these things are exactly same, and this has to be equal to 0. If the tangent is anything is parallel to x-axis, the slope has to be 0, because slope or m or tan theta is the angle with x-axis in the anti-clockwise direction from the positive x-axis. So we have fx as y, which is x square here. So this is a polynomial function. Polynomial function is continuous also and differentiable also. Then fa equal fb, you don't have to do it because there is nothing Rolle's theorem in the question is being indicated. But we have to do it using the Rolle theorem, that is fa and fb. If you take negative 2 and 2 also, then what you are going to get? Negative 2 whole square and positive 2 whole square. So you'll get 4 in both the cases. So the third condition, this is the third condition. Final condition is you just have to differentiate this x square and equate it to 0. In here you will get x equals to 0. So at x equals to 0, which is lying between negative 2 and 2, if you make a number line, 0 is exactly between negative 2 and 2. X is equal to 0. That is what we are calling it as C. F dash x equals to C, that x will be equal to C. So this is m equals tan theta, and we have y equals x square, negative 2 to 2. So we have x equals 0. What will be the value of y? That can also be found out, but the question is only asking about this x. So y you want to find out, just put x as 0, y will also come as 0, 0, 0. Tangent parallel to x-axis, the curve is also given, y equals e raised 1 minus x square on negative 1 to 1. Fx is equal to 1 minus x square. This is exponential because it is on the power of e. So continuity and differentiability has been established in -1 and 1 domain. F1 we will find out, F negative 1 we will find out, and if they both come as equal, then we are able to apply or solve it by using the Rolle's theorem. F1, F negative 1. Just put this value and check whether you get the same number or not. Negative 1 whole square will be 1 and 1 whole square will also be 1. So we have e 1 minus 1, that is e raised 0. Here also e raised 0, and e raised 0 is 1. Both the cases 1 is equal to 1. Anything with the power 0 will always be 1. We have the similar value, then we are going to differentiate it. When we differentiate it, we will put it as 0, and whatever value will give that differentiation as 0, that is the C, which will lie between negative 1 and 1. Let us differentiate it first. Fx is e raised 1 minus x square. So e raised 1 minus x square will be e raised 1 minus x square. Then the differentiation of 1 minus x square will be negative 2x. Negative 2x will come here. We have to equate, now this is f dash x. We have to equate it to 0. And as I said, e is a proper value. It's a number. So e raised 1 minus x square cannot be 0. Negative 2 is not 0. So only value which we get here is x. X is equal to 0. In this case also, x will be equal to 0. So this gives you the tangent which is parallel to x-axis, and this is the point on this curve, e raised 1 minus x square, which is regarded as the function indicated by y equals this one. If we see geometrically also, we see that there is some point of inversion where the a point and b point is similar. There is some point in between which is c equals 0, and where the curve has changed, and that changing point where we draw the tangent is parallel to x-axis. I hope you got the discussion and the reasoning for this. The next thing is to show you the solution so that you are able to write it and know what you have to explain to the examiner. At what point on the following curve is the tangent parallel to x-axis? So this question can first be, basically it is factor form. We can just multiply and form a polynomial function. So when you multiply this x into x is x squared minus 2x plus x minus 2. X squared negative x minus 2. So 12 multiplied by this. So we have 12x squared minus 12x minus 24. This is your fx. This same y and fx are same. We have just multiplied it. We have the domain as -1 and 2. So continuity and differentiability has been established because of the polynomial function. What about fa and fb? Let us see whether these value comes similar or not, because a -1, b equals 2 we are going to put. So 12 into -1 whole square minus 12 into -1 minus 24. Here 12 into 2 square minus 12 into 2 minus 24. Both the cases you are going to get 0. You can compute it. That is all the condition of the Rollet theorem has been satisfied. Now we can solve it using we can find out that point in between -1 and 2. For that we have to differentiate, because differentiation means the slope, and slope, that is m or tan theta, that is equal to 0 whenever we have a line which is parallel to the x-axis. When you differentiate it, 24x minus 12 we'll get x as half. So c is half, which is lying between this -1 and 2, half. Then this half, this is the value of x. What is the value of y? Just put it in this equation. 12 into half square minus 12 into half minus 24. So we just write 12 into x plus 1 into x minus 2. When you put this half in this one or the simplified one, whichever you want, you'll get 12 into 3 by 2. This is going to be 1 minus 4 by 2. -3 by 2. So 2 gets cancelled with this 12. So 4 3s are 12, 3 3s are 9, 9 3s are 27, -27. So the point you get, x comma y is 0 and -27. X and y is minus half. This is half, sorry. X was computed as half. Remember, if I would have said 0, then you just change my assertion. It is half and -27. So whatever I have spoken, this is being printed here for the solution, for the sake of completion, when you actually want to write it somewhere. If f is -5, 5 to r, that is the domain is -5 and 5, range is all the real number, and this is differentiable, and if fx does not vanish anywhere, f dash x, that is when you differentiate this function, it is not going to vanish anywhere, f dash x will never be 0, and this f -5 is equal to f5, you have to prove that. This is not plus minus, it is actually equality sign. So the function which is given, there is no function given, but all the other things which are related to the function are being given here, and the condition is also to be checked, is also given, f -5 is equal to f5 or not. They have to prove that. So this is already differentiable in the question it is given, so don't worry about differentiability, because it will be continuous also. Anything which is continuous and differentiable will always be continuous. Vice versa may not be true. A is continuous, B is differentiable. We will apply the mean value theorem, because we have not actually done that exercise, because this is a chapter for MVT also, Lagrange MVT. So we will apply the Lagrange MVT, mean value theorem. So f dash c for mean value will be fb minus fa divided by b minus a. In the previous one we have seen in Rollet, f dash x is equal to 0. Here f dash x is not equal to 0. It's fb minus fa by b minus a. B is 5, a is -5. So we have to write here f5 minus f -5 divided by b minus a. This is f dash c. What is b minus a? B is 5. 5 minus of -5 is 10. So 10 into f dash c is equal to f5 minus f minus 5. We have come up till now, but the condition here is f dash x does not vanish anywhere. So f dash c or f dash x will never be equal to 0. This will never be equal to 0. That means f dash c is not equal to 0, 10 cannot be 0, this whole is not 0. That is, if 10 is a proper number, f dash c cannot be 0. So whole left hand side can never be 0. So f5 minus f minus 5 cannot be 0. Right hand left hand side both are same. So f5 cannot be equal to f -5. So this plus minus which you see is actually not equal to sign. That is what we were to prove, that f -5 will never be equal to f5. MVT we have not seen, but we have to attempt this question, and there are upcoming exercises where we will discuss all of these. But right now this is the solution in front of you, which you can attempt if you have not followed what I have discussed. This question, examine if Rolle's theorem is applicable to any one of the following functions. So whatever you do, see, this is a greatest integer function. It will give you the lower value when you put any decimal value here. For example, 2.3 will give you 2, 5.6 will give you 5, like that. This is the greatest integer function. But if you put 5 or 9 or -2 or 2, any integer value, this function, that is the greatest integer function, will always give you the same value. That is, -5 will give you 5, -5 will give you -5, -2 will give you 2, like that. So we have to examine whether the Rolle theorem is applicable or not. Now, very clear, because you know that this is a kind of step function, so it can never be continuous or differentiable. It may be continuous but not differentiable. So greatest integer function, continuity and differentiability is the main thing. If you are not able to establish continuity and differentiability, Rolle theorem cannot be applied. That we already know. Let us see. We have greatest integer function. Fx is equal to this mod. This is not mod, basically. This is a square bracket. At integral point, this is a step function. If you put anything value between 2 and 3, it will always give you 2. 2.4 will give you 2. 2.7 will give you 2. Even 2.99 will give you 2. Only 3 will give you 3. Then you go to 3.1, it will give you 3. So this is not continuous. When the function is not continuous, it will never be differentiable also. One more thing you can check, f5 and f9, whether they are equal or not. And it is quite clear that greatest integer function, if you put 5, you will get 5. You will get 9, you will get 9, because this is a integer function. Greatest integer function always returns an integer which is lower than the value given if it is in decimal. F5, if you put this in this function which is given, this will also give you 5, this will also give you 9. That is, integer will always return an integer in this function. So 5 is not equal to 9. It was not continuous, differentiable, and neither it is following the third condition, f5 equals f9. Rolle theorem is not satisfied here. When the Rolle theorem is not satisfied here, then what to do? We can just say that the Rolle theorem cannot be applied here, but since the question is specifically asking, we have to go for that continuous proving also. To prove the continuity, we always take left hand limit and right hand limit, that we already know. LHL and RHL we compute. So when LHL and RHL are computed, we just take a value which is lower than that x, a higher value than x, and then we put it in the left hand limit and right hand limit and try to equate it. If they are equal, then the continuity is established. That is, limit h tends to 0. If you take a right hand limit, this is not LHL, this is right hand limit. So right hand limit always, if you take from some n plus h will be there. So I have n plus h minus fn by h. If you go to the left hand limit, if you go a bit lower than the value, then you have to subtract some h which is equivalent to 0, not 0 but very small number. So we'll put it here as fn minus h, because on the right it will be n plus h, on the left it will be n minus h. So I'm just saying that the first one I indicated is the right hand limit. The second one is the left hand limit. This LHL and RHL, when you see the value, and this function is nothing but the greatest integer function. When you just add something to n, it will always give you n, because if you, the first n, then we have n plus 1, the value which is lower than n is n minus 1 in the integral form. But when you put this n plus h, whatever value you get till n plus 1, this particular function will always give you n. So this will be n minus n by h. So we have 0 in the numerator, h in the denominator. You'll get a 0. N minus h, because you are going on I'm taking the left hand limit. What do you get? You'll get n minus 1. As I said, any value between n minus 1 and n, this function will always return you the value which is lower integer, which is n minus 1. So what do you get? N minus 1 minus n by h, and n gets cancelled. You get negative 1 by h. H tends to 0, h is 0, so anything with which is divided by 0 will always give you infinite. Here also the left hand limit is 0, right hand limit, left hand limit is infinite, right hand limit is 0, so left hand limit and right hand limit are not equal. When LHL and RHL are not equal, you cannot say that the differentiability or the continuity is established. So all this which I explained has to be written in order to show that the Rolle theorem is not applicable here. You have to show, because if this question is asking you about the continuity also, about the differentiability also, fa equal to fb also, and finally the point which has to lie between 5 and 9, but because the three main condition of this examination falls on its head, this is how you are going to define. So this is the LHL and RHL which I explained you, and this clearly shows that the Rayleigh theorem is not applicable on fx because continuity, differentiability, all we have already checked the differentiability just now. -2 and 2. Whatever I have done with the first part, the same thing has to be done for the second part. In Rayleigh theorem, there are certain conditions. All those conditions have to be shown by you that -2 and 2. When you put -2 or 2, you will not get any other value than -2 and 2. That is, this is greatest integer function. fa equal to fb is not equal here. Both the 2 and cannot be equal to -2. And as I said, left hand limit and right hand limit you can apply here. In this case, you will get infinite in both the cases. But that doesn't mean that the Rayleigh theorem can be applied. Because for Rayleigh theorem, continuity, differentiability, fa equals fb, they all have to be met. Then only we move forward to find a value between that domain that will give you the tangent which is parallel to x-axis, and that point is what we are interested in. Here it's not possible. First explanation for 5 and 9 falls or is equivalent to the second explanation which you see here. Both the explanations are similar. It is given that the Rayleigh theorem holds for the function at point x equals 4 by 3. Find the values of b and c. Here nothing is given. This b and c we have to compute using this polynomial and then meeting all the requirements of Rayleigh's theorem. And on that course, we will be finding b and c. So fa equals fb, and since a and b, whether we have a and b or not, yes, x belongs to, there is something missing in this question which I am going to highlight just now. fa equals to fb, then only we'll get one condition. Then there is another condition when we put f dash x equals 0. These two conditions will give us two equations, and solving that two equation will give you b and c. So I'm putting this 1 and 2, actually the domain is 1 and 2 here. I'm taking 1 for a, that is in place of x I'm putting 1, and in place of x I'm putting 2. So this left hand right, fa equals fb is already said in the question that it is there. So I'm just putting this 1 and 2 and trying to equate it, and finally I'm getting an equation. If you take everything on one side, you'll get 8 plus 4b plus 2c minus 1 minus b minus c. That comes down to, this is 3b, this is c, this is 7. 3b plus c plus 7 equals 0. Now f dash c at 4 by 3 is 0. So in Rayleigh's theorem, we put f dash x equals 0, and wherever this x brings down to 0, that x we start calling it as c. We will differentiate and just place it as 0. I am differentiating the main function. You get 3x squared plus 2bx and then plus c. This is the differentiation value, and this is equal to 0 when x is equal to 4 by 3. So replace x by 4 by 3. This is 2b 4 by 3 plus c equals 0. So there are two equations which we have right now, and your only task is to solve these two equations and then get the value of b and c, which is quite easier now. There are two equations. One is 3b plus c plus 7. Second one is 16 plus 8b plus 3c, or you can write it like this: 8b plus 3c plus 16, and this one 3b plus c plus 7. It should be written on the top of this second equation, but let it be. How to solve this? You can multiply everything by 3 in the second equation. Multiply it by 3. You'll get 9b and 3c, 21. Now don't subtract these two, 1 and 2. I'm taking 2 minus 1. So I'm subtracting 9b minus 8b, which is b. Then we have 3c, and then here you get 27. Okay, so we get a number here, and that will be negative because when you put it is equal to, because everything on the left hand side. So you get 5 here. B is equal to 21 minus 15 was 5. When we take this 5 on the right hand side, it is b equals -5. This now has to be placed in 3b plus c plus 7. 3 minus 5 plus c plus 7 equals 0. Minus 15 plus c plus 7 equals 0. C will be equal to 15 minus 7, and that will give you 8. Now b is -5, c is 8. which was to be computed in this question. So I'm just clearing it, and whatever I've spoken, this is how you're going to write it. This is the whole process you need to follow. So this is all about this exercise. Thank you so much and take care of it.